So here we are in section 1.2, which is types of data. So now we have a definition of data, and most students have heard the word before. In the statistical concept, like in this class, data are actual values of a characteristic or measurement that can be determined for each member of a population. So, it's something that, some sort of information that we're collecting. And we have another definition here, a parameter. It's a numerical characteristic, so it just means it is a number. A parameter is a number of the population. We define that in section 1.1. That can be estimated by a statistic. Okay, and I'll define that in a second. As you can see, a statistic is a numerical characteristic that represents a property of a sample. Okay, so the idea here is when you are talking about everything, so say I have a classroom and I have 30 students in it, and I find out some piece of information about all 30 students. So I find, say, all their ages, and I find the average of all their ages. That's what's considered a parameter, because it is a numerical piece of information about a population. I know something about every single person in the population. And so that's a parameter. But typically, as I said in section 1.1, we don't have all that information. We don't have, if we're going to talk about, say, every person in the United States, to actually find out the age of every single person is fairly difficult, because even if we wanted to get that and we try that with the census, it would still be a very big challenge, because some people hide in the woods. They don't want to be found. So what we do is we instead do a sample, which we talked about in section 1.1. So when you find and have a sample and find some information about the sample, we'd consider that a statistic, because it is based on the sample. And statistics are typically what we have, because again, populations are often very large and hard to get information from every single thing in the population. So now what we're going to do with that information is identify whether what we see is a parameter or a statistic. So a really good idea to see if you're with me so far today would be to pause and see if you can put either parameter or statistic in the space that's left in the box for A, B, C, and D, and then unpause and see if you are right. So for A, we're talking about the national midterm election, that's the US. It says 23.4% of the representatives in the US House of Representatives are female. So what we're doing there is we're looking at all the representatives in the US House of Representatives, and we're saying how many of them are female, and then creating a percentage of that. So the number of female over how many representatives there are, and then converting that into a percentage. So because of that, it is information all about a population. We know all the genders of the people of the US House of Representatives. So in that case, this is a parameter. Coming over to B, in a 2015 national survey of high school students, 15.5% of the respondents reported that they had been cyberbullied. So in a case like this, you want to kind of consider the word survey. You want to think about high school students, and if you think about national, which is the US, high school students, there are millions of them. So the idea that they could have asked every single student of the millions that are in high school in the US it's just not likely. It's virtually impossible to do. So because it says survey, we then say, okay, they must have taken some sort of sample, and therefore this is a statistic. For C, only 12 people have walked on the moon. The average time these people spent on the moon was 43.92 hours. And you may know that we just had capsule, when I made this video at least, that came back to Earth with 2 astronauts, Bob and Doug, and they landed in the ocean, and it was pretty amazing that we did it that way. We haven't done it that way in a long time in the US. So that's also an interesting piece of information. They were at the International Space Station. But anyway, the reason I mention that is because for all of the video quizzes, I usually have a kind of random question that just makes sure that you listen to the videos and watch them and paid attention. So I'll be putting a question about Bob and Doug on the quiz. So just make sure to make a note of that so that you can get the credit. So for C, the fact that we know that 12 people have walked on the moon. That's the population of people that have walked on the moon, 12. It's not a very big population, but it is the population of people that have walked on the moon. So having information about those 12 people gives us a parameter. Now for D, a study of 6,076 adults in public restrooms, 23% did not wash their hands. So notice, if we're only talking about 6,100 adults in public restrooms, we know that there are many, many adults that use public restrooms in these cities, that would not nearly be all of them. So that's telling us that we took a sample, and that means that this is a statistic. All right, so moving on to types of data. So we've got qualitative data and quantitative data. Qualitative data comes from categorizing, describing attributes of a population. So for example, if I was to gain qualitative data from people, I might say something like, I might record the color of everyone's shirt. That is qualitative data. I might label all the different coffee shops that are in my town. Okay, we've got Starbucks, we've got Peet's Coffee. So notice that what I'm taking there is qualitative. These are describing attributes of a population. So I'm getting color of shirts or names of coffee shops. That's qualitative. Once we get into quantitative, which really is the main one that we do in statistics, now we're really talking about numbers, and that have some sort of aspect of measurement. So the numbers have to mean something. That's a big part of it. Numbers have to mean something. So counting or measuring. So if I were to count how many Starbucks I have in my town, that would be a quantitative piece of data. I'd have a number. I have 5 Starbucks in my town. Now, not more importantly, but to be more specific, that's also what's called a discrete quantitative data. So discrete quantitative data is quantitative data, numbers, that are countable. So for example, the number of Starbucks in my town is countable. I have 5. 1, 2, 3, 4, 5. That's discrete. There's also a finite number of Starbucks. Like even if we were to look at all the Starbucks in the United States, there's a finite number of them. They don't go on forever. There is a certain number of Starbucks in the United States. Now that's opposed to continuous. So when we're talking about continuous, there's infinitely many possible values. So when we talk about continuous, we might say something like someone's height. Now you might think, but somebody's height, like I'm like 5'6". Well, that's true, but that's really because we're rounding it. You're probably not 5'6", 5 feet 6 inches. You're probably 5 feet 6 inches, maybe another little quarter, and then another little 1/8 of an inch or something like that. Because the way that we do height, we kind of just say, okay, are you 5, 5.5? Are you 5'6"? Are you 6 feet? Things like that. So height is a measure that is continuous because, imagine even just measuring anything using, say, our inches and feet system. You could use like a tape measure, and there's an infinite number of lengths that something could be. So if I were to measure the table that I'm looking at right now, it's like, is it 3 feet or is it 3 feet and like a little bit more? Another example of continuous data is our weights. So you might get on the scale and it's, probably going to say, okay, 160 pounds. It might say 160.2 pounds. But you could also be 160.3 pounds, 160.4 pounds. You can actually be 160.35 pounds. But typically the scale is going to round that. So anytime you have the ability to have a continuous number of data values, that's continuous quantitative data. So let's see. For the first example here, it just wants us to determine whether what we have is qualitative or quantitative. So see if you can take what I just said and figure out quantitative or qualitative. You can pause, do it, and then come back. So starting off with A, gender. So we have some options for what somebody might answer to the question of their gender, but they are not numbers. They cannot be measured or counted. So because of that, we have qualitative data here. This is qualitative. Remember right now, just qualitative or quantitative. B asks for temperature. So if I go outside, I'm like, oh, today's like 91 degrees outside. So that is a number. It can be measured. We can, of course, say, today was hotter than yesterday. Today was 91, yesterday was 85. And so we're going to have something quantitative. For C, number of days in the past week that you studied, you might answer 2. I don't know, school just started, so I'm not sure. But you could also say 5, you could say 10, but you are answering a number here. So you've got quantitative. And for the last one, zip code. So for zip code, this is where we kind of get into the idea of like, oh, these could be a little bit tricky. But say you have the zip code 91214 as an example. Yes, this is a number, but when we're talking about quantitative data, it should be some sort of measuring or counting some amount. And zip code is not an amount. It's not something that measures anything. It's just kind of a something that categorizes a certain place, right? A certain area, because you're in this area and this is this zip code, and you're in this area and this is this zip code. And so because of that, this is an example of qualitative data that is a number. So understand that you might see numbers that are qualitative. They're rare, but they happen. But you'll never see something that isn't a number be quantitative. And then what I'd also like you to do is, now that we've already talked about discrete and continuous, see if you are with me on that one. And go ahead and answer, just so these are all quantitative, just answer discrete or continuous. Pause, come back, see what you did, how you did. Right, so for A, the number of heads obtained after flipping a coin 5 times. So you flip a coin 5 times, you could get 0 heads, 1 head, 2 head, 3 head, 4 heads, or 5 heads. But notice that is countable. That is a finite number of values there. So because of that, this is discrete. The number of cars that arrive at McDonald's drive-through between 12 p.m. and 1 p.m. So you could count those. You could say, oh, this hour, that's probably a pretty busy hour, so maybe there were 25 cars that came through. Maybe there were 30 cars that came through. I don't know. The point being, you can count how many cars came through. So this is discrete. For C, the distance a 2014 Toyota Prius can travel in city driving conditions with a full tank of gas. Now, thinking about this, the distance. Now, we do a lot of rounding in our world, right? Like, very few people are always like, oh, I drove 30.67 miles today. People would normally say, I drove like 30 miles today, I drove like 31 miles today, 35, whatever, they're gonna round it. But we wanna understand that distance in miles is continuous because, I don't know, full tank of gas, Toyota Prius, come on, it's a lot, right? So let's say it can go 400 miles, but it's probably gonna go 415 miles, 0.724 miles, whatever, your car's just going to round it, however many miles it goes, because that's your car display panel doesn't put all the values on there. So the point is, that's what you're going to see. And so because of that, that is continuous data, because there's just an infinite number of values that fit a full tank of gas. Now, the average test score on the first statistics exam in a class of 35 students, you may or may not realize that there's always going to be that tricky one. So you might say, oh, the student could get a 90, the student could get a 70, but this asks for the average test score. So what this is doing, if you remember average from way back, whatever math you've done, is this is actually saying take all of the values of the test scores, and then I'm going to make a very, very small class here. I'm not going to make 35. I guess you could. Maybe I'll do my ... here. But you could, let's say, add up all the 35 data values, divide by 35, and the thing is that number could be anything. It could literally be anything. So because of that, we would call this continuous, because it could be a number that goes on forever, right? Because you're dividing by 35, you could get anything. And so that's an example of one that might be a little trickier. Focus, especially now, on the first ones there, and then just kind of spend some time maybe thinking about D and why it is continuous.